Earlier this year, Saudi Arabia parked its offshore drilling rigs. Dozens of massive multi-million-dollar maritime assets were powered down and left in the dark. Now, the policy has reversed. The government has issued notices to switch every single one of those suspended rigs back on. Arabian Drilling and ADES, the two major contractors operating these fleets, confirmed the resumption notices. Based on the paper contracts, they project reaching 100% offshore fleet utilization by the end of the third quarter of 2026. Those initial suspensions were a precautionary measure in response to regional conditions. The actual market demand for the underlying oil wells never disappeared. This chart shows how the market held up during the blackout. Notice the steady line at the top. That is unbroken well demand. Beneath it, the contracted utilization rate for jackup rigs, the industry term for these mobile-like supported drilling platforms, is pinned near 90%. Daily operational rates are holding firm. In fact, the fleet returning is smaller than the one that left. Major operators like Saipem sold their Saudi jackups and exited that specific market entirely during the pause. There are now fewer rigs available to drill the exact same number of wells. The financial markets see a projection of 100% utilization and assume a fleet is back to work. But an engineer sees a massive, unresolved gap between a corporate announcement and a spinning drill bit. To understand that gap, you have to look at where these machines live. An offshore jackup rig is an isolated, exposed steel structure standing in the middle of a corrosive ocean. On a financial report, utilization counts as a contract milestone. On the water, readiness depends on the physical integrity of the equipment. A suspended rig is, in reality, a rapidly decaying asset. Heavy salt air and high humidity relentlessly attack the dormant machinery. Physical failures multiply in the dark. Heavy battery banks slowly drain. Massive electrical motors sit still. Unused shafts risk seizing completely. Bridging the gap between a written resumption notice and actual drilling requires a recommissioning campaign. This is a time-intensive, highly technical repair operation. The resumption notice serves as the starting gun for the engineering team. It provides the authorization to begin reversing months of physical decay. This strict checklist is mandatory. First, electrical integrity, insulation resistance, and Megger testing on motors. Next, safety systems, end-to-end function testing of fire and gas loops. Then, revalidating the emergency shutdown system and matrices. Finally, blowout preventer recertification and a class survey before drilling begins. This checklist is entirely unskippable. The timeline dictated by the corporate press release is ultimately subordinate to the timeline dictated by safety physics. Rebuilding a human crew represents a longer timeline than restarting the heaviest machinery. When a rig goes idle, it sheds its crew. Highly specialized workers are immediately transferred to active assets or moved to entirely different geographic regions to keep working. Offshore work requires strict certificates of competency. These are legally required credentials for handling hazardous tasks, and they quietly expire on a rigid calendar, completely independent of when a rig is suspended or resumed. You can replace a degraded battery bank in a matter of days. Rebuilding, recertifying, and training a qualified rig-specific crew takes months. There is a core reality in heavy engineering: steel waits, competence walks. So when evaluating energy market recovery, ignore the corporate utilization number. Watch the physical readiness date. That gap between a signed contract and a fully crewed, recertified rig is where the real work happens.